Hi, everyone, and thanks for joining us for today's session. We're here to chat about powering real-time AI, how Cockroach and ClickHouse um, are great, two fantastic products that can work together to get you there. I'm one of your co-hosts. My name is Rohan. I'm a PM here at Cockroach Labs. I work on CDC, which will be one of the major topics here. Before we get started, we have a few reminders for you all to get the most out of today's session. A, if you have questions, please submit them via the Q&A function. We'll be taking time at the end of the session to review the QA. And B, after this session, we will be sending out a link to watch the session on demand. So if you have folks on your teams that want to listen into what we will be talking about, feel free to send it their way. So joining me today is Sai, Director of Product at ClickHouse. Sai, do you want to give a quick intro?
No, absolutely. Thanks, Rohan. I would love to introduce myself. I'm Sai Srirampur, and you can call me Sai. I lead database integrations efforts at ClickHouse. So my team is responsible for defining how databases like CockroachDB integrate with ClickHouse. Prior to ClickHouse, I was the CEO and co-founder of a company called PeerDB. At PeerDB, we made it seamless to sync data from databases to data warehouses, and that's why ClickHouse acquired PeerDB around 1.5 years ago, and that's how I made it to ClickHouse. So in this talk, we'll first give you an overview of what is ClickHouse, what are the use cases, where does it shine, and then we'll go into the better together story of CockroachDB and ClickHouse, how these two amazing database technologies are defining the era of AI, helping customers build mission critical applications. We'll also talk about how you can integrate these two technologies like with CockroachDB's change feed and ClickHouse's click pipes, right? And finally, we'll do a live demo showing this integration in action. So yeah, I'll pass it to you, Rohan, and once it's ready, we can get started. So
Cool. Yeah,
awesome.
I think
So
we can jump into it.
yeah, let's get started. So I would love to, first know how many of you here, who are attending the webinar, have heard or know about ClickHouse. I don't know whether there's a poll, but you could probably type it out, but would love to know, how many of you know ClickHouse. Okay, so I think what I'll do is I'll talk about what is ClickHouse for the folks who don't know ClickHouse. So ClickHouse is an open source, column-oriented, distributed OLAP database. It started as a project in 2009, went to production in 2012, and was supporting the second largest web analytics platform in the world. It was open sourced in 2016, and since then has been adopted by many large companies like Netflix, Instacart, Meta, and more. In 2021, ClickHouse Inc. was formed with the idea of providing a seamless way for customers to deploy and manage ClickHouse on the cloud. Number two, ClickHouse is a column-oriented database with many specialized features and optimizations around blazing fast analytics. Number three, it is a distributed database. It is available with both sharding in the open source and separation of storage and compute architectures suitable for cloud, making it fully distributed and horizontally scalable. It is both multi-master and can be deployed across regions for resilience. Last but not the least, it is purpose-built for analytics. So the laser focus is on analytics, supporting aggregations, real-time visualizations on massive data sets. Now what we'll do is we'll double click into the use cases where ClickHouse shines. I see ClickHouse shine in four main use cases, and we'll start with the first, which is real-time analytics. In this use case, many companies like HubSpot, Cloudflare, Weights and Biases use ClickHouse to power customer-facing real-time analytics. These applications typically run on operational databases that have grown large enough for analytics and start to become very slow. As a result, they require a purpose-built analytical database. ClickHouse was primarily built for this use case in mind. So I consider real-time customer-facing analytics as our bread and butter use case. The second use case where customers use ClickHouse is data warehousing. Here we have companies like Instacart, like Lyft, IBM, who use ClickHouse as a data warehouse. All internal BI and data science workloads are powered by ClickHouse, delivering high efficiency both with respect to speed and cost. The third use case is observability. So here we have companies like Netflix and eBay who use ClickHouse to store all their logs, metrics, and traces data from applications and power all their internal observability using like ClickHouse. We recently acquired a company called HyperDX and launched something called as the Click Stack. So this is an end-to-end open source observability stack that includes both like the data platform, which is like ClickHouse, and also a sleek UI, which is powered by like HyperDX. The fourth use case, which is like, the topic for today, is like AI and ML. So we consider AI and ML as an umbrella use case that spans all the three other use cases, right? So we have like thousands of AI companies like Anthropic, Cursor, LangChain, OpenAI, Weights and Biases, which is now like CoreWeave, who use ClickHouse across the three use cases of like real-time customer-facing analytics, data warehousing, and observability. In addition to that, like we have several like AI native features, including an efficient vector storage. You can create like HNSW indexes and all the stuff needed for like storing vectors. We also have CHDB, which is an in-process engine, which is built on top of like ClickHouse, which is very similar to DuckDB. And through this, you can run your like data preparation workloads, right, for your like machine learning jobs and stuff like that. We also recently acquired a company called LibreChat, which is a very well-known chat interface for any LLM. And with this, we are creating the agentic analytics stack, and we plan to make a bunch of announcements in this area in the coming 1 year. So with that, let's get into the use case that I want to double click, which is real-time customer-facing analytics, because this is where we see ClickHouse integrating with operational databases like Postgres, CockroachDB, and like MySQL and other like operational databases. Customers typically use operational databases like CockroachDB to power like transactional use cases that require low latency, create, update, delete, and lookup operations for their mission critical applications. Then they sync that data in real time, as you're seeing on the screen, to ClickHouse and offload analytics to ClickHouse. In this particular use case, over the past like couple of years, with the growing impact of AI on the world, we have seen a drastic increase in the scale and reliability demands of these like real-time customer-facing like applications. Gone are those days when like gigabytes were considered large. Now we are talking about like terabytes or even petabytes. And the same applies to other dimensions, not just data size. We are seeing this increased like drastic increase in demands with like concurrency, availability, resiliency, and more. So based on like patterns from like thousands of such customers running real-time enterprise grade like AI applications, here is what we are seeing. So real-time enterprise AI applications, number one, need like fresh data. As soon as data is generated, no matter the scale, it must be ingested and be available for querying without any delay. So that is one, that's first dimension. Second is they require like blazing fast queries with consistent response times, like in the order of like milliseconds, regardless of like any concurrency. Number three, they need to be available all the time. Essentially, they need to be always on. And last but not the least, they need to scale to millions of users. And users today are, AI agents generating like requests and like data at like massive scale. All these four needs and dimensions have to be fulfilled across like both operational and transactional workloads and also analytical workloads. That is both for creating, updating, deleting, looking up events as they happen, and also delivering blazing fast insights on that data. So this is where I see like a strong better together story between CockroachDB and ClickHouse because each is a purpose-built database designed for a specific type of workload. CockroachDB for like high throughput transactions and ClickHouse for blazing fast analytics. On one hand, you have CockroachDB, which supports like low latency, high throughput reads and writes. It provides like full ACID compliance, offers an intuitive Postgres compatible SQL interface for devs to build their applications. It's horizontally scalable, allows you to grow as the workload scales. It's also globally distributed, ensuring like high availability and resilience. Last but not the least, you can run like CockroachDB self-hosted. in the cloud or in like the BYOC, which is like bring your own cloud model. I see ClickHouse to be very similar to CockroachDB, but in the analytical world. So ClickHouse supports like real-time ingestion at large scale and delivers blazing fast analytics on massive data sets. It includes purpose-built features such as columnar storage and vectorized executions for like fast analytics. Its separation of storage and compute architecture enables like almost infinite and like flexible scalability. ClickHouse is also like distributed, fault tolerant, and it's available as open source, a managed service in the cloud, which we call as like ClickHouse Cloud, and also in the BYOC model, which is bring your own cloud model. Now, this combination is already vetted and validated across businesses. It's not just like, theory. I'd like to highlight like, a joint customer story with Cami, who built their like real-time customer facing application, AI application using CockroachDB and ClickHouse. Cami is an AI powered interactive learning platform that enables teachers and students to collaborate on digital documents like in real time. Their platform is trusted by 50 million users with presence over like 180 countries. And during COVID, they saw like a surge of 20x events in their platform. So the image that you're seeing on the right hand side of the screen, 80 million weekly events became over 1.8 billion weekly events, and Postgres was not able to keep up with this scale for both like transactions and analytics, right? This is where they migrated to a combination of like CockroachDB and ClickHouse. CockroachDB for powering like high throughput, low latency transactions, and ClickHouse for analytics. They saw significant improvement in like performance. Queries that were like taking in minutes finished in less than a second, and this is for both like again transactions and analytics. More importantly, they are worry free of future growth as they are like on databases that can scale with their workload, basically. So what I have on the screen are two testimonials that the customer like shared for CockroachDB as well as like ClickHouse, CockroachDB on the transactional side, and ClickHouse on the analytical side. Let's double click on the technical architecture that Cami followed, and this is what like we see a bunch of customers like follow. So if you see the screen, you have the real-time enterprise AI application, which is getting powered by CockroachDB and ClickHouse. CockroachDB for like low latency transactions, ClickHouse for like analytics, right? And as events happen on CockroachDB, you replicate data to like Kafka using like change feed. And I love this like feature called change feed in like CockroachDB. This was new to me since when I like started working with CockroachDB, and I worked with like a bunch of databases like Postgres, but like they don't have this feature called change feed. What it enables is it lets you like sync data as it's like ingested in CockroachDB. Like let it be like inserts, updates, deletes, all the DML operations, and also like DDL operations to external data source. So you can like put that in like Kafka or like S3. Pretty cool, basically. And then you can use ClickPipes, which is like the native ingestion service of ClickHouse Cloud, to replicate that data that is like coming to Kafka in real time to ClickHouse and make those transactions like analytics ready. And then you have your application, which is like querying ClickHouse for like blazing fast analytics. So this is the architecture that like Cami follows, where like they use change feed to like Kafka to like ClickHouse using ClickPipes. And that way like you have like the transactional ready data ready for like analytics. So this is the reference architecture. So with that, I will pass it to Rohan, who will talk about change feed in more detail. How is it implemented? Like what are the use cases? So Rohan, it's all yours now.
Appreciate it. Yeah, I mean, like Sai mentioned, change feeds basically turn your Cockroach cluster into a live event stream. So every row change is available to any sort of downstream systems in real time instead of through slow, brittle batch jobs. Or, oftentimes you end up having to stand up extra infrastructure and extra services. You think of your Debeziums, your streams of the world. But the reality is, a change feed is what we consider our change data capture mechanism. It's basically a built-in way to stream range changes out of the database in real time. So instead of running periodic batch jobs or pulling tables, you basically tell a cockroach, watch these tables And every time a row is inserted, updated, or deleted, that change is turned into an event and pushed out. Under the hood, it's basically powered by all it really needs is a create change feed statement. It's all invoked via SQL. And so it can emit to a variety of downstream systems, Kafka, cloud storage, webhooks, or even directly back over a SQL connection in what we consider syncless mode. But you can think of it as a first-class feature. So it gives you an ordered stream of changes with timestamps and flexible message formats like JSON, Avro, CSV, and most recently Parquet. And that stream can be used to keep caches and search indexes up to date, feed events into microservices in an outbox pattern, or continuously load data into analytics systems and warehouses. But it's basically how you turn your Cockroach cluster into a live data pipeline, not just a place where data sits. Um, Next slide. And here I really kind of I think I kind of really want to walk through, how does this actually work? But at a very high level, when you start a change feed job on a node, the node becomes a coordinator. Its job is to basically act like a traffic controller. It tracks the job, keeps tabs on the other nodes, and manages the overall progress. But the actual work of streaming changes is fanned out across the entire cluster. So each node doing work periodically reports back checkpoint progress through aggregator processors, and the coordinator uses that to advance a high water mark timestamp, which is our guarantee. So everything at or before a timestamp, this timestamp has been emitted to your downstream sink. And if the coordinator node dies, another node can take over and restart the job from the checkpoint. So as rows are inserted, updated, deleted, they flow through the range feed layer into the change feed encoder, which then turns them into the final message format and sends them to your sink, whether or not it's Kafka, cloud storage, or whatever you have configured. Um, and if you've enabled resolve timestamps, we'll also periodically emit those high watermarks to each partition or endpoint. Um, uh, is kind of basically how it works. So basically, your downstream consumers know they're fully caught up through a given time. I think event delivery is at least once. Um, and yeah, anyway, happy to take questions as we go along as well. But I'll pass the baton back to Sai to talk us through a quick little demo.
Awesome. Thank you so much, Rohan. So now what I'll do is I'll show this architecture of, CockroachDB, ClickHouse, like change feed, to replicate data to Kafka, and then Kafka to ClickHouse. So all of this like entire reference architecture to power like real-time enterprise AI applications using CockroachDB and ClickHouse in action. And the scope, the data set size is pretty small because like we just have limited time for the demo. But this has worked for like large like data sets of in the like billions of rows, like similar to Cami. So let's get started. So let me share my other side of the screen. Give me 1 second. So 1 second.
While Sai, you're getting stuff, I'll just answer one of the questions, which is how do you prevent back pressure or lag in high throughput CDC pipelines? The very high level answer is we have a number of knobs for fine tuning change feeds. We have a knob for basically it's called min checkpoint frequency, but it prevents your sync from being flooded with checkpoint messages. And then we also have another setting called resolve timestamp where you can set this resolve timestamp, and it you increase or decrease this particular setting, so you can sort of smooth out jitter in high throughput scenarios. So it basically acts like a natural buffer.
Awesome. So let me share my screen. Okay, can you see my screen?
Yep.
Awesome. So let me first show you the setup. So I have on one side, you have CockroachDB. which is I have like a bunch of like, this is like a sample like cluster that I have. I have like a database called test_db. So if you see, it has like three tables, like events, like a table T1 and users. So as a scope of this demo, like I will, replicate the events table using change feed, and change feed will take care of both initial load and continuous sync. So I will show both of them. And the target is, ClickHouse, and which is where you can use ClickHouse for analytics. And the way I'm going to do that is using like Kafka, which is Red Panda. So I have like CockroachDB. This is the setup, and then I have like Red Panda, which does not have like any topics. Let me go ahead and like create a topic called events_topic, and then like I create this, and then I go ahead and I'll show you like ClickHouse. So this is my ClickHouse cloud database, right? Like a bunch of them are here. I have like my database, which is like this, right? Now what I'll do is I'll show you I'll connect to CockroachDB using PSQL, right? Like and that's the beauty of a Postgres compatible layer, that I can start like using CockroachDB with like any Postgres driver or like client. So let me go ahead and show columns, right? Like, so I have around like 7 columns. If you're seeing like ID, user ID, event type, right? Like, and a bunch of different types as well. Like I have ints, I have like string, like I have like bool, right? And let me go ahead and count the number of rows, right? So I have around, you see the number of rows, there are around 1500 rows. As I said, like for this demo, like the data size is smaller, but this has worked like at scale to the billions of rows. So now what I'll do is I'll go to, I'll go ahead and run this command, and slowly as I've been playing around with CockroachDB, this command is becoming my favorite, Rohan, by the way, which is like the create change feed command. So,
So easy.
so yeah, it is so easy. So like I have like the create change feed command, which actually like takes like the table name. Here I'm using like Kafka as my like target, which is like the basically the Red Panda like instance, right? And I'm specifying the topic as well. It's like actually the events topic, if you're seeing here, right? It says the connection string, and like there are a bunch of knobs, right? Like you can like use envelope, row, you can use a bunch of other formats like knobs that like change feed has. So let me go ahead and kick this off, right? So the job got created in the backend, and now it should start pumping these like events to Red Panda. So which is like Kafka, right? Like, and first it will do like an initial load, right? And I'll also show you the CDC part where as events coming, like they will get populated. So if you see, the data is already here, right? Like, so this is like data, and let's zoom into one of the rows. Like you have like description, event type, the same like the columns that you saw like when I was like showing you like CockroachDB. Now what we'll do is like we'll go to ClickHouse. Now that like my events are like ready in like Kafka and are like continuously getting pumped, let's go to like ClickHouse and set up a data source. So in ClickHouse Cloud, as you're seeing, we have the ClickPipes service, which actually lets you start like ingesting data from many sources, right? Like you have object storage databases, and also like streaming sources like Kafka, Red Panda. So for the scope of this demo, I'll use like Red Panda, which is my source, right? And then I'll call this the name of this pipe as CockroachDB events, right? And then I'll use fill out my broker information, right? Which is all the auth that is needed on the Kafka side, right? I'll put the username, I'll specify like the password, right? And with that, I will say click on incoming data. And now if you see, it did pop up the topic, right? So it did pick up, the topic which is on the Red Panda side, the Kafka side, right? And then I can start reading the topic either from like the most recent, like which is the latest, or like from the beginning. I have to do it from the beginning because I want to get the existing data as well as to ClickHouse. I'll say beginning, and it should load up the topic. So if you see, like it loaded up the topic, it even gave you like a sample like row how it looks. You can even flatten object, right? This is very powerful when you have like JSON and nested types, right? Like, so in that scenario, you have the capability to like flatten it to like new columns, right? For this demo, I'll not do that. So like, let me go ahead and say parse information, right? So if you see like I'll pump this to like the events table on ClickHouse, so you can specify the database, right? Like, and you can also specify like the table which is like events, right? You can also like as a part of ClickPipe, we let you do a lot of data modeling as well. So you can specify the sorting key. Sorting key is nothing but you can think of it like an index, a primary key index on like the ClickHouse table. You have like a bunch like you have the table mapping, the column mapping, right? You can even change it to whatever you want, so you get that flexibility. Can also specify whether like nulls are expected or not in this like table, right? In that column, right? And then you can also like specify like different table engines. So one of my favorite features in ClickHouse is you have a concept of a table engine, which lets you like do a variety of things. For example, merge tree table engine is just like an append only table engine where like you have logs, metrics, traces, you just like shove it into this merge tree table engine. Then you have the replacing merge tree, which actually lets you, optimally handle DML operations, right? Like you have like updates, deletes, which are like, deduplicated, which you replicate as like, ingest, but like the engine itself does the deduplication and maintains the latest version of the row, right? So you have the null table engine. This is a table engine which lets you do operations on like the table without actually storing that data, right? Like, so this is very useful when you have like PII data on your like OLTP database that you don't want to store in like the analytical database. You can use the null table engine, do like transformations using materialized views. So like a bunch of like we have like tens of table engines which lets you do like a variety of things. Then you can like even partition, like you can specify primary keys and all of that, right? Like, so let me go ahead and go to like details and settings. So this is where you specify what access you want. For the scope of this demo, I'll just say like full access, and then I'll go ahead and create the click pipe. So the click pipe is getting created. So let me, okay, the click pipe is getting created. So let's give it a second. Okay, so it's running, right? And let me go ahead, go and see whether like my data is there. So like I'll go here, let me search for like events, right? Like should come up pretty soon. So let me go ahead and do select count star from events. Oops, my bad. Okay, so the 1500 events are there, right? Like, and the
Nice.
table got created, and like, let's go ahead and see, the events, right? Like, select start from events, and these are the sample rows, right? Like, which is coming from the CockroachDB table, right? And now what I'll do is I'll go ahead and add some rows to Cockroach very soon. So let me keep the count ready, right? Count. Okay, and then I'll go to Cockroach, right? Like, and uh, I'll go ahead and start ingesting 5 rows. So let me just like use the watch command, which like ingests like 5 rows every 2 seconds. Now
Hmm.
obviously this works at scale across like tables, right? Now let me go ahead to cockroach like to ClickHouse, right? And it's
Nice.
pretty fast, right? Like, so the latency that we can expect, right? Like with this approach is like few seconds basically, and yeah, the count is changing and. Yeah, and obviously, like all of these, like all of the data is also, getting into like the into Kafka. So if you go to, the topic, you'll see those rows operations get flowed in here as well. So if you see like you see the count like estimated messages, and yeah, so and also one fun thing I'll show is like you can also see the table schema. So like if you see like this is the table schema that ClickPipes automatically created. Like if you see like there are some like metadata columns as well, and we support like a bunch of types. Like we try to keep it as native as possible. And then you have like the order by, which is like the sorting key that we define and all of that. So yeah, so this was the demo that I wanted to show. I would love to take any questions.
This is super cool.
Let me go to the
First question
uh,
is how to secure this end to end.
you want to start first, Rohan?
Yeah, I mean, I think you really should aim for zero trust inside the perimeter. So I think you're going to want first step is cockroach to Kafka. and you're going to need to configure your create change feed statement to authenticate against a Kafka broker. So all three components, both Cockroach, Kafka, and ClickHouse, have to run in your private subnet with no public egress, and use, your whatever authentication you want to use with the transport security you need to use, mutual TLS or one-way TLS. Um, so at least from Cockroach to Kafka, that's totally possible. And then from Kafka to ClickHouse, you want to talk about that, Sai?
Absolutely. So from Cockroach to from Kafka to ClickHouse, like very similar to what Rohan mentioned. Basically, like make sure that it's in the same perimeter, right? Like so, ClickPipes like supports like private link, and it's like very common for like customers like in AWS, right? Like to connect their like MSK, right? Like and even like providers like Red Panda, right? Like so you connect it via like private link so that like it's all secure, right? And then like from an authentication perspective, right? Like if you see in ClickPipes, like we support multiple modes. Like the one that I went was like with Scram, like 512. You can also go with 256, right? Like so we support like a bunch of like authentication modes. So two things. One is like make sure that it's all in a private network, like through private link, through VPC peering, which is like supported out of the box. And like number two, use like all the authentication like that we already provide like inbuilt. So yeah. Any other questions?
One of the questions is how long will data stay in ClickHouse? Is there a time limit you can set?
Exactly. Fantastic question. So the beauty is like in ClickHouse, there is a concept of TTL where you can specify like expiry for your tables, basically, right? Like, and you can specify that like, hey, I want like just to store like last 30 days of data, and ClickHouse automatically like, does the expiry. So like it's all taken care of. So you specify the TTL while creating the table itself, right? Like, so that feature is already there. And we have customers like it really depends on the workload, right? Like if you're like if it's a pure transactional application where you want like every like event, every update, you just like don't set TTL. For a workload where like you're so say storing like logs, metrics, and traces, right? Like and you just want like you have your SLA for your customers to like just give like last 1 week of like data or last 30 days of data. Then you just specify the TTL and like we expire like the data automatically. So yeah.
One
Any
of the
other
questions is
questions?
also in the same setup, going back to the security question. Um, do both ClickHouse and Cockroach have to be on the same cloud instance?
Good question. So that is like the advantage of private link, right? Like so it need not be on the same cloud instance. And obviously, like if you think about it, right, like both are distributed like databases. One is for like transactions, one is for analytics. So you want to isolate hardware so that you make the most of each of these systems. But like you use like private link, VPC peering to like make sure that all of it is like is secure, right? Like I mean, private link like VPC peering from like CockroachDB to like Kafka and Kafka to ClickHouse, basically. So that's the standard recommendation. That's what like we see across customers also. Cami is like very similar, right? Like they use like Cockroach Cloud, they use ClickHouse Cloud. And in regards to Kafka, I'm not sure what their provider is. Like it could be Confluent or like it could be Red Panda or it could be like Amazon MSK. I'm not sure about that, but to make it secure, like it's all via private link and like VPC peering. So yeah.
And one of the questions is, when would you say this combined Cockroach and ClickHouse setup is a good choice fit? And I think Sai covered some of this earlier in his slides, but I think the reality is Cockroach gives you transactionally consistent, globally distributed OLTP. With change feeds, you get all your data streamed out in real time, ordered and or time-stamped and resilient. And so that means your operational systems remain the source of truth, but you're not running heavy analytical queries on them or building fragile ETL jobs. ClickHouse sort of plays this role of a high performance analytical and feature store layer, as an example, at least in the context of enterprise AI. So it's optimized for fast aggregations, time series, and sort of large scale joins, which is exactly what AI workloads need. everything from like feature engineering and model monitoring to complex exploratory analysis over billions of rows. A lot of ClickHouse's key customers that Sai was showing, I think, speak to this as well. So when you connect the two, Cockroach via CDC sort of becomes that data artery into ClickHouse. So you get a bunch of events and entity changes flow continuously into ClickHouse. You can materialize features and metrics in ClickHouse almost immediately. And so your AI system can train, score, and monitor on fresh production grade data without sort of touching the transactional cluster. So I think for enterprises, that checks a lot of boxes from an architecture standpoint. You get scalability on both sides. You get regulatory and governance friendliness. We on the Cockroach basically handles correctness and locality, and ClickHouse gives you clear, auditable, analytical data sets for AI. And importantly, we're cloud agnostic and polyglot friendly, sorry. So you're not locking your AI strategy to a single vendor's black box. So the headline really is, we keep your AI grounded in live, consistent transactional data, while ClickHouse turns that into fast, rich signals your models and analysts can actually use. So in case you want to add anything there.
I think you summarized it really well, Rohan. So yeah, I think it's spot on.
Yeah, there's a question about what is the process to deal with errors during the CDC. Target had not null, but data comes with null value or data type jobs are incorrect, for example. We have a ton of we have an entire monitoring guide actually that I wrote that walks you through the entire change feed pipeline, how to monitor each part, every step along the way. What are the high level metrics, but also, ultimately it's a pipeline and you want to understand where the marble's getting stuck and how do you diagnose if there's something wrong with your sync, whether or not that's S3 or Kafka, or is there something um, there's something bigger that needs to be addressed within the database itself, but whether or not that's like the range feed or um, or something in the processing section. But anyway,
Yeah.
there's we have ample documentation and I'll throw this into the chat as well.
Yeah, and on the ClickHouse side, right, like ClickPipes, whatever I was showing, right, like right here that you're seeing on the screen. You're seeing my screen, right, Rohan?
Yes.
Just want to confirm. Awesome. So ClickPipes is like a fully managed like ingestion service, right? Like, and we've invested like a lot on it, and like in the past like couple of years, and so this gives you like full observability, right? Like on like what is like what is the amount of data, like what is the like vCPUs that we are using. So you can even like change like settings, right? Like so you can specify like whatever table settings we initially defined, you can change those. You can like you can also like scale out and scale in, right? Like so even the ingestion service like lets you read using multiple replicas, and you can scale up each replica as well. And like we have like customers like moving like tens of terabytes like per day basically, right? Like in the cloud, and or even more. And interestingly, like Netflix like moves like over a petabyte of data like per day, like, and then it's all like their observability data, right? Like so, and then we also like if you look at the metrics, like we also show you if you go to you can go and see the errors, right? Like so there is an errors table which will actually show you like what are the errors, and obviously there are no errors because like things pass very well, so you can diagnose those errors. We also have like customer facing alerts, right? Like so if there are any issues, right, like we send you alerts either via Slack or like email or like in the notification center, right? Like so you can go and see like, and a few common like a few issues that we see is, say like you have a off stream like materialized view that you change, and like that's not fitting up well, then you get an alert saying that, guys, like you need to fix your materialized view. So like we have alerts regarding that as well. And also one thing I do want to call out is we have like we export all these metrics that you're seeing, right? Like I mean metrics, logs, etc., to like a Prometheus endpoint, which you can actually start consuming and like uh, plug into your like observability tools like Grafana, like if you're using ClickHouse, great, right? Like ClickStack or like Datadog, right? So a bunch of observability, right? Like to make it like enterprise ready. So yeah, and then from a ClickPipe standpoint, like we move over, like so far we have moved over like 20 petabytes of data. This ingestion service, and like per month we move like over around like a couple of petabytes of data across like thousands of customers. So yeah.
So one of the questions is, what other database technology do you guys support? If you want to flash up that slide that you had earlier about different
Yes.
connectors.
Yeah, so like from a connector standpoint, right? Like so we support like Postgres, like MySQL, MongoDB. You can do Cockroach. One thing that like Rohan and I have been like actively chatting about is having a more like direct native connector. This is something that we will look at in the coming like months, where like you just one click and get like the Cockroach data, right? Like and so that's on the databases side, like Postgres, like MySQL, MongoDB, and Cockroach through like Kafka, and on the and on the what you can see all of that here. So like if you go to the data sources, right, like if you say like create ClickPipe, these are all the same sources, right? Like so on event streams we have like MSK, Kinesis, like Confluent, right, like Red Panda, WhatStream, right, like and on basically object storage we have like S3, like Google Cloud Storage, right, it could be Azure Blob Storage. So yeah, a bunch of like sources. And one like the philosophy with which we run ClickPipes is like quality over quantity, right? Like so anything that we has add here has to work at scale, right? Like so we are like very depth focused and breadth focused. And obviously you can use like any other like integrations like Fivetran, like or like Airbyte to get your like data from connectors that are not in here, right? Like to like ClickHouse.
One of the questions I think, speaking of um, Red Panda and Kafka, is can you group several topics using a single click pipe, or is it one topic to one click pipe?
I love that question, by the way. So as of now, like it is, one topic per click pipe, basically, and it was, I mean, this is how we started, and the reason it has been like powerful, and we've been actively thinking whether we should like group multiple click pipes, multiple like topics into a single click pipe, and that is something that we might do in the near to medium term future. But the reason we didn't is because like that isolation of like one topic with one click pipe, number one, gives like tremendous like query like performance, right? Like so recently we had a customer who said that ClickPipes is like 5 times or like more faster than like the standard Kafka connect, right? Like so it gives you that like it gives you hardware to this topic, and like it gives you like performance. Second is it gives you isolation. Now the thing is like the way customers overcome okay managing like hundreds of topics is they use the API, right? Like so we have an API which lets you like manage all of this like very very seamlessly, and you can actually specify that like hey, for my like smaller topics I want to use like the smallest hardware, and you can go up to like even 0.1 v cores, right? So TLDR, right, like the architecture is like one topic per click pipe for performance and security reasons, but in the near to medium for term future we might actually support like multiple topics as a part of single click pipes.
That's a great, that's a great answer. I mean, I think there's a similar answer about, a similar question around, can you have uh, multiple change feeds on one table pointing to different target locations, whether or not it's S3 or Kafka or webhook? And the answer is yes. Um, Locality of the data in Cockroach. Um, and I apologize for jumping around here, but let me actually answer one of the other earlier questions, which is what happens when things fail. My guess is that this is effectively an at least once, and it'll prefer to resend anything it can't be sure was act. Um, yes, that's we are the entire pipeline operates on an at least once delivery guarantee. Um, and that's effectively what happens. I think if and I'm just thinking about different scenarios that where this is relevant. If the Kafka broker crashes or becomes unreachable, I think we will attempt to resend the batch with what we call exponential backoff. Um, and so we'll continue to track changes in our internal storage, but we don't queue them indefinitely in RAM, so we rely on the database's storage engine. And I'm happy to talk about this in more detail, but I want to make sure that we focus on some of these more the questions that sort of hit the confluence of both Cockroach and ClickHouse. But the reality is we have a mechanic to deal with, we have a back pressure mechanic to deal with not being able to reach the sink. We allow you to pause change feeds and resume change feeds. If a Cockroach node fails, for example, our internal job system will detect the node goes down, and then another Cockroach node claims the change feed job, for example. Um, and if ClickHouse fails, Sai, do you want to talk a little bit more about kind of what happens if like a click pipe fails for whatever reason?
Exactly. Like, I mean, it's kind of very similar. So we have a retry logic, right? Like, which actually uses exponential back off under the covers. And so it keeps retrying, right? Like, and then and for an hour, if like, for like few minutes, actually tens of minutes, like if there's it's still not getting fixed, then we actually send an alert to the user that guys, like, either it's authentication or a materialized view or like sources, like, like not, up. So we send alerts, right? So this is a fully like, enterprise grade like experience where like, you have retries, like you have, alerts, you have like exponential back off. And fun part is like, right before the demo, Rohan, right? Like I didn't have the Red Panda events topic, right? And the thing that I loved is, it errored out, right? Like, and I could see, the change feed saying that, hey, the topic does not exist, like in one of your like logs table. And then like I created the topic, and within like 10 seconds, it actually started pumping events, right? Like, so, yeah, that was pretty cool. So, yeah. And the same with
Easy ways to
ClickHouse.
get around failures. Go ahead, Sai.
Awesome. Yeah, exactly.
And I think one of the other questions is how does locality of the data in Cockroach affect the change feed configuration? We have an execution locality um, uh, flag on the create change feed statement. So we handle data domiciling with change feeds primarily through this option. So it sort of it constrains where change feed processor is run by specifying locality filters. And so this filter only, or sort of this option only controls where change feeds process data, not where the data is stored. Um, so true data domiciling, if that is the fundamental question, requires combining this execution locality option with proper multi-region table configurations and zone configurations to sort of pin the data to specific regions and having the sync, in this case, Kafka and ClickHouse in the same region as well. But it's all possible. ClickHouse can read from Redis side.
Redis, like we don't support it yet, basically. So in the data sources, you see like we don't support Redis. But like again, as I said, like you can move data to like Kafka and then like suck data from like Kafka, basically. But as I said, right, like we will be adding more like connectors. Like for now we have like Postgres, MySQL, MariaDB, like Mongo. BigQuery is something that we will be launching very, very soon. So it already came out here, but like, and then like, for CockroachDB, like we're actively working with like, the Cockroach team, Rohan, to get something in here. And then, very similar to Redis, right? Like, so you can expect like more connectors to come out this year. But like we follow a very like depth first versus like a breadth first, right? Like, so any connector that is in here, right? Like Red Panda, like, it works at scale. So yeah.
And I think going back to I'm curious to look at your SQL console here. Can you join the output of multiple click pipes in a materialized view?
Oh yeah, absolutely. So you can do like many things, right? Like, so if you go to the SQL console, you can query across databases. You can like create like, for example, here I have like select count star from events, right? Like, which is my table that I'm getting from Cockroach, right? Like, and then I can actually join it with I need to set the for events, not event. Okay, perfect. So I can now see it's like 4,695 rows. It's like the insert is all happening here, right? Like, so yeah, so I can like join. It's just tables, right? Like, so you can join them, like power your analytics on the raw data, or you can create like materialized views. And materialized views are like a very powerful like feature in like ClickHouse. And there also there are like many types of like materialized views. So like you have aggregating merge trees, like which actually, let you like aggregate data on the fly, right? Like we also added, we have both incremental materialized views and refreshable materialized views. So refreshable materialized views are like, uh, um, it refreshes like the entire like view, right? Like every few minutes, every few like, seconds, like whatever you can specify the interval. Incremental materialized views are like more as the data gets in, like, it performs the operation, whatever is defined in like the view. So you can join it. There are some considerations where like, the, the join is triggered when like, the left side of the table, the left table is like added, like when you add new rows to the left table, right? So all of it is documented, but yeah, you can do joins as well as a part of the like, materialized views, or you directly query them and power your like applications. Yeah.
Super cool. And just to be clear, you also support Mongo as a connector, right? So I can connect a Mongo collection if I had one.
Yes, we do. Awesome. Any other questions?
Any other questions?
This was great, by the way. A lot of
Do we have
questions.
an article covering the security end to end of what we just talked through? No, but that's something that Sai and I can chat through on how to make it clear around how to um how to make a deployment in security conscious orgs.
Yeah. And on the, I mean, on the, ClickPipes side, like we do have ClickPipes. If you just search for a private link, right? Like, and then this actually captures like, for like, MSK, right? Like, so this is like Kafka, right? Like, so how do you set up like, so bits by bits, there are docs. I'm sure like you'll see that on the change feed side as well on Cockroach. But we will be actively working on converting all of this to like, official docs and a blog, right, which will capture like security as well. So yeah.
Yes, this is exactly it. Almost sounds like bringing OLTP and OLAP capabilities together as a unified platform. That is fundamentally what we are trying to do. There are a lot more questions, but I think we've also
I
covered a
love
lot of the
it.
stuff. All of this setup possible on my local machine. Uh, if you can run Kafka locally. You can run Cockroach locally. But running ClickHouse locally, so I'll
Oh,
let you comment on
absolutely.
that
Yeah.
one.
Yeah. ClickHouse, you can run locally. We have like Docker images and it's fully like open source. So yeah, you can do all of that basically, right? Like, so yeah.
Totally possible. With a few minutes left, I think Sai, you wanna we have some goodies for all of you who are still with us. Um, w- scale out, scale up with Cockroach Cloud and see the resilience for yourself. Um, ooh, Arguably, we should have shared this with you earlier, but for those of you who are getting started with your journey, we have $400 in free credits on this QR code. So take your pictures now because this will not be sent out in an email afterwards. But we're looking forward to seeing those of you who are new to Cockroach and ClickHouse uh, jump in the shallow end with us.
Awesome. And the same thing we have with, ClickHouse. So like there is an additional $100 cloud trial credit, right? Like which total sums up to like $400. So you can give this a shot, right? Like, and you can even like test out ClickPipes that I showed you to start like, pumping data from like different sources. So yeah, you can expect like docs on everything that we like showed in the demo soon.
For
Yeah. So
sure.
with that, I think that's it
I think we're
from
gonna
my
wrap
side.
up. Thanks for all the quiet time and all the questions. Sai, it's always great to connect and it's been awesome seeing all the cool stuff that we can do together. As a reminder for everyone else who's joining us, the session will be available to watch on demand later this week. So we'll see you. We'll see you soon. Signing off from the two of us. Take care,
See
guys.
you guys. Bye bye.